Electrostatics. Let's look at some of the key information in this section. Here is some of the formulas. This is the main formula that we use. Please take note of the conversions that you need to by heart, just in case they give it to you in another form like this, you need to change it back to coulombs. Here's another formula. When the spheres touch and move back to the original position, you need to use this formula. Q1 meaning the charge on the first one, the charge on the second one divided by 2, which will give you the new charge. And make sure you include signs. And if they ask you how much electrons are transferred, you'll say Q1 after the contact, meaning this new amount that you get here, minus the Q1 initial, which they gave you initially, and then that is your coulombs. However, they ask you electrons, so you need to use this formula to work out the number of electrons. The factors of magnitude forces are the charges and the distance between their centers. When using the F formula, meaning this one, don't include signs, and when using the net, include signs. There are two types of graphs which you can acquire from your formula. The main one that I showed you previously. This and this are on separate lines. Thus, they are inversely proportional, and this is on the same line, thus directly proportional. Please have a look at your formula, and you will be able to derive the graphs using that. We will dive right into the past papers. Two charged spheres, S and P, on insulated stands with a charge of 5 and -6, respectively, are placed 0,02 meters apart, as shown in the diagram. Remember, you need to convert these to coulombs. State Coulomb's law in words. This is something you need to by heart from the guidelines. Calculate the magnitude and direction of the electrostatic force that sphere S exerts on sphere P. This is your main formula. Sub everything in. I told you don't include signs. They're just converting it here times 10 to the -6. Don't include signs, just sub everything in and you come out with an answer. Don't forget direction. Sphere S and P are brought into contact with each other and then return to the original positions. The third negatively charged sphere R with an unknown charge is now placed 0,01 meters to the right of sphere P as shown below. Calculate the magnitude of the new charge on sphere S after being in contact with P. Remember, 1 plus 2 divided by 2. 1 plus 2 divided by 2. Both spheres now have this charge. Sphere S and P both have this charge. And in this one, you don't forget the sign. Draw a free body diagram showing all electrostatic forces experienced by P. P is this one. You need to know this is negative, and this is unknown. However, S, P, or P, being P in the middle, because that is what is experiencing this force. The magnitude of the net electrostatic force experienced by P due to S and R is that. Calculate the magnitude of the charge on R. This is fairly simple. You have everything. They give it to you. You just sub it into the equation and you get an answer. Calculate the magnitude of the net electric field at a point 0,01 to the left of R due to the charge on S and R. Electric fields is something we'll be looking at in the next video. I'll explain it, but we'll go into more detail in the next video. So you have the force of both of these. Your F net You have the negative 84, which they given you in the previous question, the negative 450, which is here, and the positive 5,625. You sub everything into the equation, and you'll come out with 2 times 10 to the negative 6 coulombs as your F net. Remember, coulombs, that's why 10 times negative 6. This will be the last past paper example because the next video is going to be directly linked to this and we'll do more examples there. 3-point charges X, Y, and Z are arranged as shown in the diagram below. The charges of X and Y are so. Point charge Y experiences a net force as so in the direction of 32 west of the line YZ state Coulomb's law in words. This you have to learn directly from the guideline and it was given to you earlier in the video. Draw a label free body diagram to show the electrostatic force on point charge Y due to the point charges X and Z. Also indicate the net force on point charge Y. We're working with point Y. This is a negative, this is a positive because this is the one we'll be moving, so it'll be moving that way. Z does not have a charge, however, there's a net force given. So this will have to move downwards since it would be negative for this to be positive. Like so. The F net always goes directly through the middle. What is the nature of the charge on point charge Z? Choose from positive or negative. I did mention this now. It is negative because of the net force. Calculate the magnitude of the force that point charge X exerts on Y. You have to draw a closed vector triangle diagram and it should look something like this. You have your F net that they've given you and it has to be a 90-degree triangle. They've given you 32 in the question. 90 minus 32 is 58. That's how you solve your triangle. Now once your triangle is solved, it becomes pretty simple from here. You sub everything into this formula and you should come up with the answer of 2,65 times 10 to the negative 3. Charge of Z. Now you already have your charge here. You have your F, which you sub as 2,65 and you sub everything in, which would give you the charge on Z.